Yeah, I will. You know, we talked about nuts and bolts of product specs and processors and 3x3 and that, but from what my presentation is going to be is I'm going to dive into what I do every day. I know some of you are consultants, you use multiple vendors' products to do different designs, and that's pretty much what I do for Xirrus. Is I live and breathe, you know, I've been on the interop team for 4+ years now. I early on was involved with putting gear in the Geneva Convention Center for a worldwide radio show. We've done the Farnborough Air Show. You know, I get thrown at all these projects, and in some cases, you know, here's your basket of parts, go make this work. And sometimes, as we all know as wireless engineers, we're trying to do the impossible because of the limitations of the technology. So that said, you know, some of the large public venues is we've been involved with are, you know,
where's Scott Stapleton?
What's that?
Yes, exactly.
Yeah.
Right there, bottom left corner.
So, you know, I refer to it a bit as a kind of a perfect storm. We're asked to provide connectivity to thousands of users in you know, small spaces. Some of the different things we have to do is adapt and all kinds of different clients, and I mean, it's just, you know, it's kind of a perfect storm of what we're being asked to do. And I've been involved with, you know, you look at the large public venue space, there's convention centers and arenas and stadiums and open fields, and even in all of these large public venues, you take a convention space, there's anything from a keynote that we've been involved with doing designs for 15,000 people, for example, for Dreamforce in the South Hall of the Moscone Center. But then there's also, you know, there's the back of house, there's the point of sale, there's not just, we generally on large public venues will focus on the high density stuff, but there's also, you know, just regular traditional Wi-Fi that we may use a 2 radio device in the back of house, or in stadiums there's suites where, yeah, it's, you know, medium density kind of stuff. It's not ultra high density where the stadium bowl or the arena bowl is. So, you know, that's one thing that, you know, I try to, when I get involved with a design with a customer, is to make sure I understand really what their need is, and not just say, oh, you know, we got to go figure out how to make wireless work in this bowl. So obviously understand the intended device that you're going to use, because as everybody in this room, I'm sure, well understands, and those watching, is not all devices are created equally. I mean, you can sometimes design a great wireless infrastructure and scanners, and this driver or that driver of a wireless device can drive you nuts. So generally I try to get involved up front and be proactive. Give you an example, I'm going to be working on a large event that's coming up that they plan on, at the event there's 12,000 attendees, they plan on giving away 12,000 devices at the event.
Google. Excuse me.
Nope. Been there, and we did some of that though. And I try to be proactive and say, okay, let's get one of those devices in our hands and find out, you know, what we can do proactively before we turn these people loose at this event, and find out, oh, you know, the driver said it supported 5 gig, but oh, really, it only supports the lower uni and the upper uni 3. It really doesn't support DFS. To part of what Sam was touching on earlier, is, you know, the client side and, you know, the whole adoption, and, you know, some of that, if you dig into the research of it, you find out part of the reason they do that is it comes back to the process of getting something approved through the FCC. That's, you know, that doing the DFS approval process is lengthy, and we all know in this business, you know, time to market, churn, you got to go fast. Sometimes they'll skip that, and that's sometimes that's the reason why a product doesn't support the DFS channels. Purely boils down to as a business decision. So anyway, just touching on, you know, that's something that becomes very key. And in those large public venues, here again we think about just the attendees, but, you know, there's all kinds of video, digital signage, there's all kinds of different architecture from a wireless perspective that I get involved with. Yeah, there's the attendees, but then you have to think about, how do I have channel reuse that I allocate or dedicate for, you know, certain aspects of that. One is I do a lot of work with a large software company in the Northwest, and we not only provide wireless in the keynote setting for the attendees, but they're crazy enough they want to do wireless demos live on the stage using Wi-Fi in that environment. And I'll show you a spectrum analyzed shot of what we've done in that to try to use that. Here again, the other side of it, where I see, you know, events that are not successful, that people have tried this, is they don't think about the oversubscription ratio of the internet pipe when you're trying to set up a large public venue. I've been in convention spaces and other large public venues where they'll say, oh, we're good, you know, we've had 1,500 simultaneous connections on our network, you know, just bring your arrays and we're good to go. Well, then you start finding out, you know, their firewall has limitations of simultaneous TCP sessions, or their NAT tables are limited, and, you know, all of these different back-end pieces that I always tell people, you know, the RF's the one piece of it, but you really have to stop and think about the back-end system that you're tying the RF to, because, you know, we're used to, in some environments, you know, maybe 1,000 wired connections, but when you move into a property that you can now provide 10,000 connections, it's just, you know, the scale of things. I use the analogy of, you know, I can invite four of you over to my home and cook you a very nice meal. But now if all four of you want to now bring 500 of your best friends over because that was a good meal, my kitchen just doesn't scale to that. And sometimes back-end networks, we run into those problems, and I'm sure if we sat around the table and chatted about it, you guys have similar stories from some of the things that you've done. Some of the stuff that we've come up with and I use as we go through designing these networks is defining what the user density is and trying to, you know, define from an engineering perspective of what those numbers are. And anything you see from me today is examples. As you all know, this is always a changing, moving market, and as a network engineer gets asked a question, 99% of the time we're going to say, well, the answer really depends, because I need to know this, 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 and this. And these are numbers that I've used over time, and as Xirrus as a company have used. Here again, some more guidelines depending on what you're doing. I'm using instructional and demos in the sense of, in a lot of the large public venues, we will have spaces. Like last week, I was at Black Hat, and Saturday through Tuesday the space was set up for classrooms, anywhere from, you know, down to 22 up to maybe 60 users in a given space. And so you have to think through and say, okay, they're going to actually be using the wireless as you would much in a classroom type of environment. But then Tuesday night, all the air walls break, and now we're, you know, anywhere in a keynote setting that's set for 3,500 people to, you know, maybe some of the briefings were as large as anywhere from 60 upwards of 384 users. So here again, depending on how that environment of what you're designing to, you need to understand and obviously engineer to that. The other thing that I talk to people about is, you know, they sometimes say, oh, we got this event of 10,000 users and we got to figure out how we put enough radios in the air for 10,000 people. Well, generally, the simultaneous associated people, that number generally is somewhere between 30 and 50%. And then you have to think through and say, okay, of those 30 to 50% of the devices of number of people there are associated, how many of them are actually concurrently doing something? Because if you get too carried away, I mean, there's times where you can't even, you know, get the internet circuit into a venue based off of math of saying 10,000 users, 1 megabit each simultaneously. I work backwards from that and find out, okay, this many attendees, what do we think, you know, what's the demographic of the users? And I'll talk about that a little bit in one of the examples of some data that I've had gathered from an event. You know, I kind of picked the top 10. I have a ton of other design principles that I kind of live by and share with others, and try to share the knowledge in the company and the community of, you know, obviously we're seeing fewer and fewer B devices. I mean, we cut that off a couple years ago of in any high density environment. No B support. Obviously channel planning, and Dirk touched on, you know, how we channel plan and what the array is doing, and there's times not to, you know, he and I have oppositions on that, but there's times where, depending on what you're doing in a dense environment, and I give him feedback all the time to his algorithms, because there's some hidden commands under the hood that I can get and see what the arrays are seeing each other, that he can feed back in to the algorithm and try to continually make it better. But there's times where I do manual channel plans, and sometimes that's what it requires. You know, one other item that, you know, I've seen really mixed results is rate limiting clients. If you have enough bandwidth, you know, let the device get on the air, do what he needs to do, and get off, rather than limited him and he sits there and chugs along, takes up, you know, time slices in the air, and he's, you know, using more air time to accomplish the same thing. So all depends, here again, that, you know, that answer, it depends on what it is you want to do. The other thing I've seen is, you know, DHCP scopes become a problem, because people think, oh, I'm not going to have that many simultaneous people associated. Question?
So you're suggesting there to disable the 802.11 in bonding so that you're using 20 megahertz, I guess, instead of 40 megahertz channels.
Yep.
And I know Keith has actually done some testing that was showing that using 40 megahertz gets to be more efficient, because you get the clients on and off much faster off the channel.
That I concur with you.
But I also concur with you, because it's all about density.
Right. Well, it's all about density. The other thing that it's all about is channel reuse, right? I've got to create cells, and I can only reuse that spectrum efficiently every so far. So if I bond everything, now my channel reuse ratio just basically doubled, or, you know, was divided in half basically. The other side.
So what I was getting at more is your experience of working with these really, really dense clients environments is that in the end, the balance between the two comes down more on the side of the 20 megahertz channel reuse scenario than actually trying to get them clients on and off quicker.
Yes. Yep. And part of that comes down to is the clients themselves. You know, there's still a lot of single stream or single spatial stream devices out there. They're not going to take advantage of the bonding anyway. They don't support it. So at that point, you could be providing something to, you know, an upper small percentage of devices that could actually even take advantage of that. That's the other thing I see.
Okay.
Any other key points on there? I think I covered all those. And then I'm going to jump into a demo right quick of XMS, just to show you live of this guy is Mosconi's XMS, the Mosconi Center. It's probably not going to be anything really earth-shattering today. I had hoped they would have something big going on, but currently what it is, it's the American Bar Association in the West building. And, you know, just to kind of give you an idea, as you can see, they've got currently online now only 115 users, not pushing much bandwidth, but to demo XMS a little bit, obviously, you know, the things we care about from a high level is, you know, are our arrays up, what's going on with the environment, the station counts, the wireless throughput, you know, from a 10,000 foot level.
Can I interrupt you and ask you a question that came in on Twitter regarding stadium deployment?
Sure.
I'll just verbatim here. Related to stadiums, their array doesn't solve the distance, data rate in long sections, no external directional antennas. A lot of times, like with Cisco stadium antenna, very high gain, very focused with the, you know, their approach, and other people do it similar. How do you answer that?
We have, for that type of deployment, and I've got an example I'll show you I had actually used the 520H, which has external connectors on it, and very similar to what the Cisco Stadium is. I mean, you get in those environments, placements of radios, you know, to be able to plunk an array in some of those areas. It's overkill for the area because you can't control the RF enough. You've got to have some more, you know, more directionality to the radios, create smaller cell sizes, fewer radios in, I call them zones, as you zone that. So to answer that from a stadium perspective, we do have a product that has external antennas.
Yeah, several products actually.
Yep.
Yeah.
So
a 3x3 and a 2x2.
Thank you.
And then obviously things you're concerned about in that environment, you're looking at, you know, station count, in this case Moscone obviously. They could have multiple tenants in their property simultaneously. Like they may have a customer in the North Hall, the South Hall, and the West Hall all in the same day. So from a, you know, high level, you can kind of see what the percentage of clients is based on SSIDs. You get some client demographics of what those clients actually are from a manufacturer's perspective. Here again, we can break it out and show what the capabilities are of the devices that are on. Take a look at that from a high level. Start to look at, you know, some of the applications that are running across the network on those given devices with the application control information we have. And I threw a couple of graphs up here to show, you know, if I'm looking at what's going on with Google traffic, what's happening with streaming media, we can have a better look at that. Then the other thing is, you know, from this perspective, then you can jump down, you can look at you want to look at a particular array. Let me see if I happen to pick one that has some clients on it, and then from that, I didn't pick one that had any clients on it, but I can go from, you know, a 10,000 foot view down to an array's view down to a station's view, and where we're a little bit limited on time, I don't want to spend a ton in here. We'll have to come back and.
So a question came in from Twitter if there's a new Wi-Fi inspector coming in the future.
A new Wi-Fi inspector?
Not at the moment. I mean, that's a Windows-based application, so it works with Windows 7 and 8, and we've been keeping it, you know, available for all those platforms. At the moment, there's not a specific plan for an update. So.
Okay, thank you.
One, you know, kind of bouncing through what you can do at the array level. If an array has a radio set to monitor, I know you guys at the geeky level, you'll appreciate this. That radio monitor that's, you know, across the country, whatever, and some competition does this as well, but I can use that as a packet capture radio. So in that environment, I can, you know, grab that, download that, suck it up into Wireshark and look at that. And we had a feature, and it's got kind of shelved, but it's coming back to where if you happen to use OmniPeak, you can actually do a remote via SSH and then tunnel back over SSH and be able to take that monitor radio and do a packet capture right back into OmniPeak simultaneous and actually real-time watch what's going on.
And that has to be in this monitor mode? You can't do it off of a live client servicing radio?
No, it needs to be in monitor mode to be able to do that. Yep. And so bounce through that.
The maps.
Yeah, I'll bounce through, you know, show you a map. This is a map that one of the engineers there is currently working on, and he was all right with me showing it, but I'll show you. You can look at and place arrays on a floor plan. One of the things that I do when I'm doing that, looking at how radios are laid out in a given environment, is I'll turn on the IAP info.
As we look at this,
and
again, I know we're running out of time, so let me throw in another question.
You bet.
Do you have the capability for like RF groups and you know, a set of APs can have different data rates on different radios for like old scanners while everybody else is doing?
Just to clarify, in the architecture of the array, every radio you can basically there is some global settings, but like the mode they're in, like you could set in a radio to be B only if you wanted. And every radio in the array could either be configured as 2, 4, or 5 gig, obviously not simultaneously. So like say you've got some scanners you need to support that are still B. You could turn, you know, some radios that are B only, and that's basically you're building at the PHY level, kind of like what we would do with, you know, I'm going to put in a 10100 switch, and the clients that only support that, I'm not going to hook them into my gig switch, or, you know, some kind of an analogy like that you can take at the PHY level of the radio and configure them. Does that answer the question that come in? Okay.
And SSIDs can be configured globally or by radio. You can have individual SSIDs per radio.
Yep, you can, you know, kind of the analogy is we're trying to bring to the Wi-Fi a little bit what I use is, you know, what we were able to do with layer 2 switching and VLANs per port. You can pretty much do that per radio. So I could say, you know, I've got an SSID called Mike, and I'm going to squirt that out of 3 radios, and I have another SSID called Keith. I'm going to put that all 8 radios, or, you know, only an SSID out of 1 radio. So you can start carving up the air and or radio architecture for potentially different services, if you will.
Hey Mike, you got a 5-minute warning.
And so just to give you an idea, you can visually, you know, be able to, when you place arrays on a map, you can look at that. And I'm going to, from that point, I'm going to jump back to, because this is where the rubber meets the road. This happens to be a keynote at a recent event. And there's 4,000 attendees at this event. At this event, the vendor that put the event on gave away actually 2 devices to the attendees. One was a Acer tablet, and the other one was a Surface Pro. So it was really interesting to watch. And as I talk through some of the numbers, well, let me back up. Some of the things that I've done, I've worked with this vendor since 2008. We used to hang arrays from the truss work when they put up the lights and the speakers, and that worked. And then we went to the floor around the perimeter. And now, because of the density of users, the applications, what they want to do, I said we can no longer be that far away from the clients and get the channel reuse and get the density of what you want to do. So I worked with them, and one of their event companies they work with that do a lot of work with them, I says, build me a box that I can put in the space of a chair, and I'll put the array in that, and then we can get back to shrinking the cell size with a multi-radio device, and, you know, get the density up in these environments. So we've done that. I've done things as, you know, at a Dreamforce at one point, we put arrays, all 5 gig, and I call it the RF sandwich, arrays, all 5 gig on the truss work, and then we actually put some 2 radio devices under the seats. 5 gig up here, 2.4 down here. But now we're getting to the point we've gone to, you know, deployments like this, and obviously this is a temporary setting, but
coffee table.
You know, you can do something very similar, and this gives you an idea. This is just the keynote. So there's 21 arrays. Yeah, about 21 arrays in this keynote setting. You can see that in those 2 periods of time, we saw 5,044 unique MACs that was on the network at some point. Any pink concurrency was 1,740. Went the wrong way. It gives you an idea. That's how much traffic we were driving just out of the keynote during that period of time. So pushing, you know, cut it off roughly 225 megs. And then this is the across the event. This number here is kind of key, the 7916. There was only 4,000 people at the event. We saw nearly double the unique devices on the network at one point. And at any given point, there was a peak simultaneous users of 3,805 users or 3,805 devices. And this is the volume of traffic that they were pushing during the event. So this is all Wi-Fi traffic. So to give you an idea, this is, and I bring this up really quick, I just turned the Wi-Fi on in this environment out of the box, full power, just let it run. I did a little bit of channel planning. You can see what it does to the spectrum. And excuse my picture from my phone, but after I got done tuning the spectrum and done the same walk through the aisles, you can see you get much better utilization of the spectrum by actually, you know, doing some tuning to the Wi-Fi rather than just saying, you know, more power is better. So
I can't just deploy this?
No.
Who knew?
Then one really quick here is this is actually 200 phones. So you want to talk about the density. There's 200 devices in 32 square feet. And this is the spectrum that was running that. That was actually some Windows phones that you can control with an RT and drive that map and do different things with this. And obviously you can see we was only using 4 channels. This was also happening on an exhibition floor. And I mean, it was just phenomenal to get to have, you know, that kind of an environment to see how the RF behaves and how you can tweak it. The other thing I want to talk about, a little bit answer to the question that come in about the radios. Our radios and a lot of tuning and tweaking that I do is not only on the power, but we can also control the power individually per radio and also the receive threshold per radio. So I can get really interesting of how I start to try to tweak and shape and tune the RF in these high density environments.
Okay, I think we're...
Have you met the guys from 7 Signal?
Oh yes, I have. Yes, I have. We've been having a chatter on the backside, and then really, are we out of time? If I got to stop? Okay.
Yes.
All right. Next time I get to go first. Yeah. And we'll actually get into the array, and maybe I'll have some, and we'll say, okay, let's get into the nuts and bolts of some of this stuff. So thank you for your time. Appreciate it.
Thanks, Mike.
Thank you.